Antoinette Brink, PathoFinder. Multiplex detection of 24 targets in real-time PCR within 2.5 hours.
Situated in Maastricht in the Netherlands, near the German and Belgian borders. We are specialized in infectious diseases, and today I want to talk to you about our SmartFinder technology. Our R&D, production and administration all happen in this building and in line with the regulatory ISO 13485 and, sorry, can you click again? The IVD medical devices regulation. So in infectious disease diagnostics, used to be the question, my patient has pneumonia, for example, it is the influenza season, I just will look whether it is influenza that is causing this patient's disease, and if it is not, I will look for something else. So that has been completely replaced by the syndromic approach, meaning what organism is causing my patient's illness. I want to look at everything at the same time, and therefore I need a highly multiplex PCR test. By the way, I don't want to buy an expensive new instrument, and it has to be fast, of course. For that purpose, we developed the TwoSmart technology. The first step involves a multiplex primed target enrichment. And in the next step, so the couple of slides that I will show you in a bit all happen within the same tube, there is a signal amplification. And that is directed by a multitude of hybrid primers consisting of the universal sequences, which are in orange and gray, target-specific sequences in yellow and blue, and detection sequences in red. We call them the stuffer. And note that during this step of the process, there is a label incorporated, that is the green dot. Simultaneously, in the reaction mixture, there is a multitude of probes present, and they can hybridize to a stuffer sequence when a product has been generated. The probes are also labeled, and this leads to emission of fluorescence that can be measured. Now, the number of different labels and the number of different sequences in the probes, they determine the multiplexing capacity of the assay. And at the end of the reaction, the temperature is gradually increased, leading to a sharp drop in fluorescence as the probe dissociates from the product. And that is the peak that you can observe. This is actually what it looks like in one of those conventional real-time PCR apparatuses. You can see here in 2 different channels, in total 12 different samples representing 12 different pathogens. So each peak represents 1 pathogen, and you know which temperature is related to which pathogen. So the optics of the conventional real-time PCR apparatuses do not allow that high multiplexing. We want to detect 24 targets in 1 tube, and that is why we are now optimizing all our assays on a new machine with different optical properties. Thank you very much.